quick review of parabolas, basically. So everyone should know that a parabola is like a U shape, right? So a parabola can either open up or open down. And that point where the parabola turns and goes back up or turns and goes back down is called the vertex point. So that is called, label that right there, is called the vertex point. I don't know if you remember that. You should remember that from Algebra 1 or geometry. You may have talked about vertex. All right, so that point right there is called the vertex point. Now, recall standard form of a parabola. F of x equals, we're going to do all functions, ax squared plus bx plus c. So when you see this form, the x is squared basically, and then it can be multiplied. The x squared could be multiplied by an a, and then the x can be multiplied by b, and then there's some constant number. That's standard form. So example of standard form would be like y equals 3x squared minus 4x plus 5, right? So that would be example of standard form. Factored form is when you see the factors and then you could see the roots right away. So we did that. So an example of factored form might be f of x equals, so like any value a, like say 3 times x minus 3 x plus 2. In this case, you would know that the factors, or setting the factors equal to 0, would give us the roots, which are the x-intercepts. Remember we did that earlier in the year? So this would be x equals 3 and x equals negative 2. Those would be our x-intercepts. So in factored form, we get x-intercepts, which is excellent. But it doesn't give us enough information to graph the parabola. So we're going to want what's called vertex form in order to graph our parabola. So what we learned today, vertex form, combined with what we do in lesson 30, you'll be able to write the equation of parabolas. All right, so let's think about, first of all, we have the parent function. You'll hear that in this lesson, called the parent function. That's x squared. Y equals, or f of x equals, x squared. That is the parent function for all parabolas. All right, so here is x and y axis. Y equals x squared is this graph right here. It has the turning point at 0, 0, and it goes up. Now, anything you do to x squared, if you negate it, if you multiply by it, if you add to it, you can create this, right? Well, that is what we're going to be doing, but I do want to call your attention that, see here, you have a number times x squared plus a number times x plus c. All that stuff, all this stuff here, moves the parabola. It does stuff to the parabola. So what happens? What happens to that parent function? That parent function is just our basic parabola. Well, vertex form of a parabola is f of x equals a times x minus h squared plus k. This is the form where you can kind of tell, not kind of tell, this is where you can tell what the vertex is. If we can get the parabola in this form, we can easily identify the vertex, which will help us graph the parabola. A is the vertical stretch. We talked about that earlier in the course. That a value, whatever's in front of x squared, that determines how stretched out the parabola is. So the more stretched out it is, the more thin it kind of will look, and then the less stretched out, the more squished it is, the more it kind of goes out this way. So that when that number is a fraction, the parabola kind of goes out like this. But when it's a bigger number, like 3, 4, 5, 6, the bigger that number gets, the more it does this. It kind of makes it go in, because it's stretching that parabola up and down. All right, so that's what that a value does. The h value, whatever comes after the x, is the horizontal shift, and this you might want to put here is always opposite direction. Just put opposite direction. We're going to talk about that. Opposite direction. And the vertical shift is this k value after the x minus h squared plus k. That's the vertical shift, and that's the actual direction it would go. And this, right now, you're just looking at a bunch of letters. It's probably confusing for you. Once we get into the examples, I think you'll get the idea of it. It just takes some practice, just like everything else. So let's get right into it now. So I want you to, in the first one, state the coordinates of the vertex. That's all I want you to do is state the coordinates of the vertex in part A. Looking at this equation, x minus 3 squared plus 5, the vertex is going to be hk. So whatever the h value is and whatever the k value is, that's the vertex. Similar to circles. Remember circles, the center point of the circle was hk. Well, when you do a circle, think about a circle. You have that center point and everything else on the circle is based around that point. Well, when you have a vertex, you have that end point or whatever, turning point, and then it goes off from there. So it's a very important point on there. So that hk is kind of like, you can kind of think of it from when you had a circle. The h value, remember what is x, real quick, let's go back to circle equation again. Oops. So a circle equation. If it was, and this is kind of off topic, don't write this down. If a circle was x minus 3 squared plus y plus k squared, I'm sorry, y plus 1 squared equals 25, right? You would say that the hk was 3, negative 1. Because x minus 3, but it's x minus h, so the h value had to be positive 3. We talked about that. Well, that's kind of how it works for parabolas too. If you have x minus 3 in the parentheses there, it's actually the opposite direction. So instead of a minus 3, it's actually a plus 3. So hk, for this particular parabola, the h value is going to be 3, but then the 5, it's just plus k. So there is no minus. It's not x minus h. Like here you see it goes x minus h, so you had to negate the h value, or you had to negate anything in that position to get h. In this case for k, you don't. You just leave the k alone. So it's just going to be 5. So my h is going to be 3, my k is going to be 5. That's the vertex of the parabola. That's where the turning point is going to be. Now, does the parabola open up or does it open down? That's pretty much all you got to worry about now. With a 3, 5, oops, I didn't mean to do that. We have a 3, 5 vertex, that's part A. Part B wants us to sketch and label the function and its parent function. So 3, 5 is going to be, we're just going to go, you're just going to make your own scale. 3, 1, 2, 3, 4, 5. All right, so we have this 3, 5 right there. Roughly is going to be our vertex. And it's going to, because the a value is positive, it's going to open up, up, up. Now the parent function is y equals x squared. So y equals x squared, we already talked about y equals x squared. Right there, it intersects at 0, 0. So you see how our parent function is always going to be y equals x squared, and we'll label that y equals x squared, and then label this one, you know, g of x. I'll just label it g of x. Okay, and that's y equals x squared. Notice how from the parent function you have a shift. The parabola shifted up into the right. Up into the right. It went 3 to the right and 5 up. 3 to the right and 5 up. That's exactly what happened to the, and again, you should have done this in Algebra 1. If you didn't, that's kind of why we're doing this lesson, to kind of give you some review. So from the 0, 0, notice how it went 3 right and up 5 because of the 3, 5 vertex. 3 right, up 5. That gets written x minus 3 squared plus 5 in the equation. We'll do another one here. So how about this one? X plus 6 squared. So my vertex is going to be negative 6. And then we just keep the negative 3. So you have to change the sign in there just like you would for a circle, but then the k value is whatever you see, minus 3. So my parent function, tough to draw parabolas on here. My parent function looks like that with a 0, 0, a 0, 0 turning point, and 0, 0 vertex. Negative 6, negative 3 is my shift now, or my new vertex. So it's 6 to the left and 3 down. 2, 3. 6 to the left and 3 down. There's my new one, and because it's negative, it opens downward. So now it's going to do this. So we're just sketching. We don't know exactly what it looks like. We know it looks something like this. Okay, we're just sketching it the best we can with no grid or anything like that. All right, so shift left 6, down 3, negative 6, negative 3, left 6, down 3. Okay. Example 3. Oh, and we label these two guys. All right, example 3. Now, parent function excuse me. I have a vertex of 4, negative 5. Positive 3, so I'm opening up. It's going to go up still. 4, negative 5, so to the right 4 and down 5. And somewhere right there maybe. Change colors. And it's going to open up still, but because it's a 3 stretch factor, so it's going to stretch it out. And so I just know it's going to be a little thinner looking. I'm just going to kind of reflect that in my sketch. I know it's going to be a little thinner than my parent function because that 3 there, that's what that does. All right, so there it goes. You can see the shift. Right 4, down 5. Right 4, down 5. That right there shows right 4, down 5. Notice how the horizontal shift goes the opposite way because it's x minus 4, but that's because 4 is the vertex, the x value of the vertex. So it does shift it to the right 4, even though it's x minus 4. All right, write this equation in vertex form. So now we're going backwards. Well, we're given the vertex. All right, so I know it's f of x equals a x minus h squared plus k. Now a is 1. They said a equals 1. So f of x equals 1. I don't really need to write anything there. X minus h. Now h is 3, so x minus 3 squared, and then plus k, but k is negative 2, so minus 2. So there's our function. Pretty simple going backwards. Now, last thing in this video, example 5, I think that's, yeah, we got the warm coming up. All right, so example 5 and 6, here's the directions on how we're going to go from standard form to vertex form. So here we go. And just kind of follow along. I'm not going to read through this with you, but I'm just going to do the examples, and then you'll kind of see it when you practice it in class tomorrow. You'll get the hang of it. We have standard form, y equals, this is like y, f of x is y, so we're going to write this as y equals x squared plus 6x minus 8. That's standard form. We want vertex form, so we want it to look like this when we're done. We have to use our method of completing the square. Remember, we did it with circles, where you have to take half of the b value and square that and add it to both sides. And then you create a squared binomial. That's what's happening here. See how you have a squared binomial? We want to create that, so we're going to have to put our own number in there. So remember how to complete the square. Get rid of the c value, whatever that is, minus 8, that constant, move it to the other side. So it's going to be y plus 8. You're moving that minus 8 to the other side. Equals x squared plus 6x. Now I can't factor x. I can factor x squared plus 6x, but I'm not going to be able to do it with a square. I need that square binomial. So I want this. Remember how we did the circles? It's very similar, except you only got to do one of them. It's actually easier than the circles. You only got to do one. Only the x is squared. All right, so half of 6 is 3. Square that and you get 9. We're going to add 9 to complete my square, but you can't just add it to this side. You have to add it to this side. So this is going to be x plus 3, x plus 3. That completes our square. See that? So now what do we have? We have this. We have y, change colors. We have y plus 17 equals x plus 3 squared. That's my square binomial. And then I want it back in function form, so I need y equals, so I need to bring that 17 back over. And there it is. Y equals x plus 3 squared minus 17. And I have my vertex form. There it is right there. The a is 1. X plus 3 squared minus 17. X minus h squared plus k. See that form right there? We'll do it again. We'll do one more example for you, okay? So y and again, you would just put f of x in for y. X squared minus 10x plus 3. Got to get rid of that 3, so it's y minus 3 equals x squared minus 10x. Take half. I'm going to do it without the factoring this time. If you like having the factors there, go ahead and put them in there, just like I did this one. Half of 10 is 5. 5 squared is 25. That's what we're going to add to both sides. We're going to add 25 to both sides. So I'm going to get y plus 22 equals, and this is going to be x minus 5 squared. Hopefully you're getting the hang of that. X minus 5, x minus 5. And then subtract the 22 over. So y equals x minus 5 squared minus 22, because you got to bring it back over. So f of x equals x minus 5 squared minus 22. And that is it. That's our vertex form. So a couple things we learned in this lesson today. We learned how to sketch using vertex form and how to get from standard form to vertex form. I'll see you in class tomorrow for more practice on these skills.